Hello everyone. So this is the second video of the series where I would be solving leetcode problems with you. So this is problem number 12, integer to Roman. It's a medium difficulty problem and has been asked in companies like Google, JP Morgan and Amazon. So let's start reading and understanding the question first. 7 different syllables represent Roman numbers with the following values. So the syllables are I, V, X, L, C, D, M, and the values are 1, 5, 10, 50, 100, 500, and 1000 respectively. Roman numbers are formed by appending the conversion of decimal place values from highest to lowest, converting a decimal place value into a Roman number into a Roman numeral has the following rules. So the first line which this says is Roman numbers are always written from highest to lowest values, and there are certain rules that needs to be applied when converting an integer to Roman number. Let's see what these rules are. If the value does not start with 4 or 9, select the syllable of the maximal value that can be subtracted from the input. Append the syllable to the result, subtract its value, and convert the remaining to Roman number. So, what this rule says is if our input number does not start with 4 or 9, we need to select the syllable with the maximal value. Please do concentrate on the word maximal here. It does not say maximum. Maximal means, let's say if the number is 9, we need to select the syllable that represents 10. 10 is the closest to 9, so that's maximal. Similarly, if the number is let's say 400, the maximal would be D here, because D represents 500. So we need to be careful there. And then what we have to do is we need to subtract this from the input and append the syllable to the result. We need to take one array which would be our resultant array. We need to take a string which would be our resultant string, and there we need to add our syllable, and later subtract the value and convert the remainder, whatever we get from the subtraction, to Roman numbers again. And the second rule would be if the value starts with 4 or 9, use the subtractive form representing one syllable subtracted from the following syllable. For example, 4 is 1 less than 5. So 4 is IV and 9 is 1 less than 10. So 9 would be IX. Only the following subtractive forms are used. 4 is represented as IV, 9 is represented as IX, 40 is represented as XL, 90 is represented as XC, 400 is represented as CD, and 900 is represented as CM. So I think this point is pretty much clear. In Roman numbers, what happens is if the value it starts with 4 or 9, we need to use the subtractive form. And to create a subtractive form, what we have to do is the maximal value we need to append the next closest lesser value to it. So for writing next closest, not the smallest value, let's say we have to write 4, so we would write IV. For 9 we have to write IX, which means 1 subtracted by 5, it represents 4. 1 subtracted by 10, it represents 9. Similarly, for 40, what we do is we write 10, we write x, L. X represents 10 and L represents 50. And for writing 90, we write x, C. X represents 10 and C represents 100. So this means 10 minus 100. Similarly, 400 and 900 are also written. And the last rule is only power of 10, which is I, X, C and M, can be appended consecutively at most 3 times to represent multiples of 10. You cannot append 5, 50 or 500 multiple times. If you need to append a syllable 4 times, use the subtractive form. So what this rule says is, let's say if we have to write 3, so we can write 3 i's together. But if we have to write 4, we cannot write 4 i's together. For 4, we have to use the subtractive form, which is this one, IV. Similarly, if we have to write 300, we can write C 3 times to represent 300. But if we have to write 400, we cannot write C 4 times. We have to use the subtractive form, which is CD. Okay. So these are the 3 major rules. And let's see what else is given. Here we have certain examples which show us how we need to how our inputs are going to be, how our outputs are going to be, and there are some explanation. Let's see what is the constraint. The number that would be given to us would be greater than 1 and would be less than 4000. And also let's go through one of the examples here so that we can better understand. Let's go for example number 2. So the input number is 58 and the output is L, V, 1 and I 3 times. Explanation. So we'll start with 5, which is nothing but 50. So 50 is represented by L and 8 is represented by 5 plus 3. So here we have L, V, triple I. Now let's see how I have approached this problem. So the function int to Roman gets a num. Later on inside the function, what I have done is I have defined an array nums. This nums contains all the numbers, all the big numbers that have their respective syllables written in the ROM array. So M represents 1000, CM represents 900, D represents 500, CD represents 400, and so on and so forth. Now what I have done is I have named another variable Roman number, which is nothing but rom nom, and it is basically of string type. Then I have an I which is equals to 0. This I would represent the indices of nums and rom. Now while our number is true, it's not falsy, we'll go through this loop where we'll check for condition, and this condition would be if num is greater than equal to nums at I. So if the number that has been provided to us, let's say if the number is 50, let's say if the number is 50, so if 50 is greater than equal to nums at I is 0 and nums at I is 1000, then we'll go inside this loop. Otherwise we'll go to else loop and do I++. Since the condition is not met, we'll go to else and we'll do I plus plus. Then the um, nums is at 900, then it will check again if um, 50 is greater than equal to 900. Again it will be false, so it will go to else and the I would be increased to 2. Similarly, it will eventually reach a point where it will be year and I would be 6. Now I would be 6. So now again it will check if num is greater than equal to nums at I, and this time it will be true. So what it will do is it will take rom number and it will append rom at I, which is it will append the value of 50, which is L, in rom num, and in let current, which is a variable to temporarily store the current value of the nums at I. So nums at I is 50. What it will do is it will store 50 in it, and the number that we have, it will subtract it from uh, so next what we will do is we will subtract the current from the number itself. So now nums would be 50 minus 50 is 0. We'll again go for the while loop and we'll see that nums is now 0. So we'll exit this loop and we'll return the rom number, which is nothing but L. So this is how our solution would work. Let's say if the number was 58, like in our example 2, so there would have been a remainder of 8. Again we would have gone through this entire loop and first we would have written first we would have come to 5, then we would have appended um, 1 3 times. So this is how it works. Thank you.